Welcome to Developer Days for Serverless.
Allow me to introduce the dream team. We have Brett McGowan, who is based in New York, a developer advocate, and Martin Omander, a developer advocate, usually in California, currently in Sweden. And I am Dina Graves Portman. I am a developer programs engineer on the Serverless team, and we are all delighted to be here today.
And you may have seen us before on Serverless Toolbox. If you go to serverlesstoolbox.com, you'll see all the past episodes. This is a show where three of us and others get in front of the camera and explain to you how to solve various business problems with GCP serverless products.
And they take up a variety of formats. There's short, kind of 3 to 5 minute, sort of lighthearted, silly videos. You can see we've got some lollipops in these, to long format, almost hour long, really hands-on, writing code from scratch, building things using Google Cloud. And as a little bit of a preview there, this is an unreleased episode featuring Dina. So you can see the green screen still in production. So stay tuned to learn all about webhooks.
What is that on your head, Dina?
It's a cat. It's because of CatTube, which is the really great, totally real company that we're helping in this episode.
CatTube, I like it. So we're talking about serverless today. And why would you want to go serverless? Well, you get auto-scaling, you get a fully managed compute platform, and that results in greater speed to market.
And I think a lot of this is around focusing on what is important to your organization and what you do uniquely well. And that's probably not in managing infrastructure for a lot of folks. So these attributes like invisible infrastructure and pay as you go really help you make the most out of your development and your DevOps team.
So let's use our imagination and imagine that we're all developers. I know that's a hard one. And we are building a web application from scratch. If we're doing this on-prem, the first thing that we need to do is to ensure that we have these yellow boxes in place. But the yellow boxes are really hard to get right, and we don't really want to deal with them, do we?
No, especially not as an application developer. So, funny story, I was a web developer at a previous company before Google, and we managed data centers. So, we had these data centers that we managed for our customers. And one day, there was a truck driver who was driving near one of the data warehouses, and he fell asleep. And his truck plowed through the wall of the data center, took out rack after rack of server, destroying networking equipment, and it was all hands on deck for weeks at the company to try and restore data that, of course, turns out people aren't doing the backups that they should have been. We weren't doing the backups that we should have been doing. It was a huge ordeal. And as a poor application developer, web developer, I'm just trying to align things using HTML and CSS. Like, my plate is already full. The last thing I want to do is go try and recover data from these destroyed hard drives.
Oh, good Lord, that sounds like a nightmare. Okay, how do we make our web applications truck-proof? We can move them to the cloud, but we're not home free there. Now we need to worry about scaling, VM provisioning, and cluster management. I'm a software developer. I don't know much about cluster management, and I don't want to know much about cluster management. I just want to build a web app. So is there a world in which a simple software engineer can build an app without worrying about all of this underlying infrastructure? How do we get rid of these green boxes? We move to serverless. Serverless products allow us to write software without worrying about the servers. Hence, serverless. And I'm an application developer. So I will focus on what I love to do, which is develop applications. And I'm just going to hang out in this blue box up here on the top left-hand side. And our ops friends and site reliability engineers, they're going to hang out in this top right-hand box and really focus on performance monitoring. And finally, they don't have to worry about constantly checking, is this machine alive? Is our database alive? Is everything scrambled? Has a truck taken down all of our servers? They can shift their focus to more meaningful metrics that are meaningful to the business. For instance, how quickly can we load this checkout page that's really important to getting our customers through our system?
So serverless, it's a little bit like the difference between on-prem custom systems and serverless. It's a little bit like the difference between getting a custom house and a fully furnished house. So right now, I'm in a full house that was not custom built. So I did not select the site, the lot. I didn't buy the lot from the city. I didn't submit building permits. I didn't choose all the different types of flooring materials and trim and decoration. And I didn't choose what glass should be in the window panes. But on the other hand, I didn't get a house that was exactly the way to where I had to pick everything. But on the other hand, I could buy it and move in a month later. So that meant that I didn't have to go through that whole process of getting an architect and working on the house for several years. I could move in, and now I can worry about what to cook for dinner and what to watch on TV.
Oh, and one of the things that I like about this analogy is sometimes you do need a custom house, both in the real world and in the world of cloud. Sometimes you need to build a custom building because you're building a store that has like certain needs, or you're building a filming studio where you need to have specific requirements around acoustics and what kind of materials it's built out of and all of that. And there's equivalents in the cloud world, like you're doing really heavy duty machine learning or long running 3D model rendering jobs that maybe aren't a great fit for serverless, but there are a ton of use cases that are a good fit for serverless.
So yeah, for example, I think Brett, Dina, and I, we all wished we had been in custom-built filming studios right now, but here we are in our homes instead. It's fine though. So let's talk about one customer and their experience with Google Cloud Platform Serverless. There's a company called MediaMarkt. Those of you who are watching this from Europe, you know about MediaMarkt. Those of you calling it from Americas may not have heard of them. They're kind of like Best Buy in Europe. Best Buy has about 1,000 stores in the US. MediaMarkt has about 1,000 stores all over the European Union. They were founded in 1978, and they sell electronics, consumer electronics.
So, cool case study. MediaMarkt had moved a number of on-prem applications to cloud. They moved enough applications that they had a really good estimate on how long it took to develop and then migrate the application from on-prem to cloud. So they had this estimate, and then as a test in the scientific method, they decided to build and deploy directly to Cloud Run. And thanks to the serverless nature of Cloud Run, there were so many steps that they didn't need to take. For example, load balancing or configuring a service mesh. And so they were able to get their app to market 8 times faster. So to recap, by moving to Cloud Run, they were able to simultaneously reduce complexity and increase velocity.
So in the end, this application, there were 3 engineers who worked 2 days to build this. They ended up building one containerized app. Containers are good. If you're working with containers, you probably know why they're good. We'll talk more about that later in the main session. They built one container that they could deploy without dealing with the complexity of Kubernetes. And this was not just a toy app either. This is a real app that real customers use all over the European Union today. So they get about 5.5 million requests per day.
And one thing I like about this that I want to point out is the latency. So when we talk about serverless, one of the great things is that you only pay while your code is running, which is great. But sort of the flip side of that is if your code hasn't run for a while, your cloud provider might sort of shut down some of those resources. So they're kind of sleeping. And then when a request comes in, it may take just a little bit of maybe a few hundred milliseconds to start those resources back up. So you could run into what's called a cold start. And this number here, 700 milliseconds, I think is a good way to start to think about cold starts. Think about your latency in terms of the average or the 90th percentile, how that affects your user, and is it actually a good fit? And in this case, it was a great fit for MediaMarkt, and they got this level of volume of traffic for only 500 euros a month, which is great. So hopefully we've shown you a little bit about what is serverless and why it's useful. So later we'll talk in some detail about specific use cases.
Please join us in the main session.
Welcome to our session. We have Brett McGowan, a developer advocate from New York, Martin Omander, a developer advocate usually in California, currently in Sweden. And I am Dina Graves Portman, and I am based in California.
In this session, we're going to talk about serverless cloud computing and the actual tech architecture you might build, and some real life use cases of how you would build different types of applications. And you'll hear us talking a lot about the 3 different compute products within Google Cloud. So there's App Engine, Cloud Run, and Cloud Functions.
And I think this slide is a nice way to just get a quick overview. There's a lot of overlap between these products, but just at a glance, App Engine is designed for web applications. So really quick web apps that users are interacting with directly, or maybe HTTP APIs. Cloud Run, which is similar, it does HTTP services, but that are container based instead of source code based. So these run containers. And then Cloud Functions, which is more of like using little snippets, small single purpose bits of code to glue cloud services together in kind of an event driven distributed way.
Okay, let's start by talking about App Engine, which is a very good place to start because it is the OG serverless product. It was launched in 2008 when I was still in college. This predates everything, even AWS. And the takeaway there is that this is a stable, mature product used by tens of thousands of businesses. It is a proven, reliable solution for building web apps. It has the right abstraction, web framework that supports routes and HTTP methods. It requires minimal latency. It supports custom domains, and it also supports Java, Python, Node.js, Go, PHP, Ruby, .NET, all the popular languages. So if you want to build just, your standard web application, then this is probably a good option for you.
The next option, if you remember from a previous slide, was Cloud Run. So this one runs containers. And because it's a container, you can put whatever you want inside that container. So you can use any language, any runtime, any libraries, even binary libraries that can run on Linux, you can put inside your container. That means you can port these containers, and you get the goodness of containers without having to deal with the complexity of running Kubernetes. It feels like every third word I've used here was containers. So maybe we should talk about what containers are, Brett.
Definitely. So containers are an industry way of packaging up your application, but not just your application code, but also everything you need to run it. So this is all the way from an operating system level to system dependencies, to system libraries, to your runtime, and then your application itself. And why they're useful, I like to think along 2 axes. So flexibility, like Martin said, pretty much anything you can sort of run in a container. You can choose your operating system, choose your programming language, whatever works for your business. If you have legacy dependencies you need to include, you can do that. So it gives you a lot of flexibility in terms of what kinds of applications you can run. And then the second is portability. So once you've actually packaged it into a container, it runs the same on your laptop as it does in staging, on the production server, on Kubernetes, on Cloud Run. It's a consistent runtime environment because it's virtualized. It includes the operating system all the way up. But because it's a container, it starts much, much faster than a virtual machine, which allows things like Cloud Run to scale up and down really, really quickly based on traffic and requests coming in and out.
Yeah, I remember in my startup days, I would sit there and write my Java code on my developer machine, and everything would work great on my developer machine. And then we would deploy it to production, and everything would break. And it was because the Java version was different up there in production, or there was a library that I on my developer machine. So deployments were always painful in those 3 startup versions of all the libraries are in the container. So you'll get less of this sort of a developer, shrugs and says, "Hey, it works on my machine." So that was 2 of the 3 compute products. We have one more to go, right, Dina?
Mm-hmm. Yeah, finally, we have Cloud Functions. So I think the way to think about this is every sys administrator has dozens of shell scripts laying around. For example, at midnight, you might have a script that moves this file from here to there. At 1 a.m., you delete this from a database. Then you upload it into your data analytics warehouse. And then something else happens in a file system. And then you do this other thing totally in another place. And so these are like short little functions, about 20 lines long. And it just glues your entire system together. But the problem with running these scripts on a developer station is that it's less than ideal, and it could get taken out by a truck. And if your computer goes down, then your system is in trouble. And so that's why we use Cloud Functions. And it offers a lot of features. They're triggered by events. You can do background tasks. It's really reusable code. It offers retries. You can do source code based deploys, and it currently supports Node.js, Python, Go, and Java.
I really hope a truck won't take out my laptop right now because I'm right next to it, so I'll be in trouble if that happens. So Cloud Functions can be seen as this sort of glue that sits between, you see here, various events that are happening out in the world in various systems, like files being dumped into cloud storage or database values updated in Firestore or PubSub messages. Various things happen in the world, and then you want to have a little piece of logic, like Dina was saying, 20, 30 lines of code that then just crunches that, reacts on that, and then just makes a call out to another piece of the world, another service in Google Cloud Platform, another service out in the world somewhere.
Yeah, and I'd like to call out that most of these triggers that you see on the left-hand side, those are native cloud integrations, which are really great because you can set them up and not have to think about them very much. It kind of just works out of the box. But what I want to call out is the HTTP endpoints that it offers, because this allows you to do integrations with basically anything in the world. So if you have your own system running on-prem or even in like another cloud service or in a web application that you want to do something when something happens, then you can do a post to this HTTP endpoint and then trigger that function. And that's how you can do integrations with anything.
Anything, right. And if that sounds interesting, do check out Dina's episode about webhooks on Serverless Toolbox. It is released shortly. It may be released by the time you see this. So let's talk about another customer and what they're doing with serverless. If you're like me, you have kids at school age, and if you're in an English-speaking country, there's a pretty good chance that you've had this company in your house, Khan Academy. The other day, my daughter was actually listening to a video about quadratic transformations. I'm still not quite sure what that is. But Khan Academy, as you may know, they started as the founder creating videos for his cousin to teach his cousin math. And then others got interested, started watching, and others got interested in creating videos, and it grew and grew and became a non-profit, which actually now has videos about many more things than just quadratic transformations or math, and in many more subjects, many more teachers creating videos. So now they have more than 2,000 videos. At that point, you can't really just cobble together, hand code some HTML and point people to various places. You need a better system to handle these 2,000 videos. And you also, teachers and students will start to ask you for additional functionality, like grading, tests, logging in as a student, save your progress, logging in as a teacher and see the progress of your students, that sort of thing. And you can only go so far with sort of cobble together a few scripts. Eventually, you need a more comprehensive solution. And that's why Khan Academy chose App Engine. With App Engine, they could do all those things in one single solution. They didn't have to build out a patchwork of systems. And developers could focus, they tell us, 99% of the time in building out functionality, troubleshooting functionality, rather than managing servers and setting up environments. And of course, as you can imagine, when everybody was stuck in their house, Khan Academy saw a big jump in traffic. And a few weeks ago, they posted a really interesting blog post on their developer blog, or on their tech blog, where they talked about how they dealt with this huge increase in traffic. And basically, what the blog post says, you should go and check it out. But basically, what it says is because they were using App Engine, it just worked. They didn't have to spend engineering hours on dealing with this increase of 250% of traffic.
Awesome. So now we've seen the way App Engine can really help a company. So let's talk about cloud functions, and we're going to go through an example showing the architecture in action. So to start with, in this example, imagine we have a fleet of deployed IoT sensors that are reporting temperature data via an HTTP post request to a cloud function. The body of the request is JSON payload with the ID of the sensor and the temperature in degrees in Fahrenheit. So our app needs to write this data to two places. One is Firestore, which is the operational database for the app, and BigQuery, which is our data analytics warehouse, so we can do the analytics and reporting for the IoT data later. Traditionally, we would put this code into one function in our app that writes both to BigQuery and to Firestore. But we ran into a little bit of trouble by doing two things in one function. If, for example, there's an error in our code that writes to BigQuery, or if we temporarily can't reach the service, well, we risk losing that data both from BigQuery and from Firestore. We can potentially retry the function, but then we risk double writing to Firestore or rerunning any of those other side effects the function might have. So we want to decouple these functions so that if one fails, the other one will continue to work. And if we need to retry one function, we don't accidentally rerun the code in the other function. However, we don't want to explicitly call those functions from post temperatures because we don't want post temperature to be responsible for retries. The solution is to use pub/sub to decouple our functions. So the only thing that post temperature does is publish the JSON message to pub/sub under the readings topic. This nicely decouples our first function from having to know about or retry any of the following functions. Then write BigQuery and write Firestore functions listen for messages coming in on the readings topic, and then they take action. And if one function fails, pub/sub will handle retrying the function for us. And that brings us to the demo. Take it away, Brett.
All right, so let's actually see that architecture and that system that Dina talked about. Let's see it in action. All right, so here are the three functions that Dina talked about in our example architecture. Post temperature, which takes the HTTP post from the IoT sensor, and then a function that writes to BigQuery and a function that writes to Firestore. I've written a little shell script to simulate the actual IoT sensor posts. And it's going to post 10 different readings and just randomly choose a temperature value so that we can see our code in action. So it's posting 1, 2, 3. And we also tied in here a handy little Google Sheet so we can see the status of the posts. So you can see it says trying when it's trying to write to Firestore or write to BigQuery. And then once it actually succeeds, it changes it to success and then color is green. So everything is good. Our function is, both functions are up and running, no big deal. But now let's say the Write BigQuery team, the data analytics team in charge of this function, goes in and they make some code change. So I'm going to edit this function. And I'm just going to use the built-in Cloud Functions editor. You can deploy Cloud Functions using your command line or using an API. But there actually is an editor, which is really nice for kind of quick little edits like this. You can see it's listening on this readings cloud pub/sub topic. And let me go in here, make this a little bit bigger, and find the Write BigQuery function, which is here. You can see this is where it updates the sheet. And I'm going to simulate an error by just, instead of the readings table, I'm going to write it to the readings table. So maybe they let their snake intern come in and edit that code. So I'll hit OK and deploy. And this may take a minute or two. So while that's doing that, we can look a little bit about some of the things you can configure on Cloud Functions. So here we've got a little reporting chart. You can see how many times it's been invoked. And then also some metadata about the function. So what region is it in? Cloud Function is available in many regions across the world. How much memory was allocated to it? Maximum timeout. So you can say it'll only run for up to 60 seconds or 2 minutes or 5 minutes or whatever. The identity that it runs in. and then a bunch of other settings, one of which is the sheet ID. So that is actually the ID of the Google Sheet document that it's updating the status in. So this one here. So let's see if our function is finished deploying. It's still deploying. But so you can see there's some other attributes you can set. As I said, you can edit it using the built-in editor, your own IDE, or through the API as part of like a CI/CD system. So you can have it be part of your natural workflow. You check code into GitHub to some particular branch, passes some automated tests, and then deploys to Cloud Functions. So as this write BigQuery function is finishing deploying, we can also check here in Firestore if we want to see the data. So you can see these are all the sensor data points that I just ran with my little shell script. And there we go. So our function has finished deploying. But again, I just deployed a broken function. I typoed the name of the table. So now when I run the little shell script that simulates those IoT postings, you should start to see it fail when it writes to BigQuery. So let me go back to our tracking sheet, and you can see it's succeeding when it's writing to Firestore, but it's failing when it writes to BigQuery. So let's say I didn't actually know what the bug was. I'm the other team, and I see, oh no, I'm getting all these failures. What's going on here? So I can go back to our Cloud Function, and I can say view logs. Now, one of the things about serverless is a lot of the debugging and sort of monitoring tools that we're used to, we can't use because there is no server to install them in. There's no monitoring solution that we can install on this transient servers that instances that come up and down. So we're reliant on our cloud platform to do the capturing for us. We have insight into what our functions are doing. So one of the things we have is called cloud logging, which automatically picks up all of the console logs or error outs to the console from your function. Not only Cloud Functions, but also Cloud Run and App Engine and Compute Engine and all of that. And that gives us the ability to automatically look and see errors that are happening in our application. So I'm going to go here and I'm going to look in this write BigQuery function, and we'll see I have, looks like I have some errors for sheets quotas, but actually what we're looking for is an error on. So I'm just going to, I'm going to cheat a little bit and look for readings since I know that's the error, filter through this. And so you can see in our logs, we've got, error, table not found, Cloud Funcs, readings. Oh no, that snake intern got in there, typoed the name of the table. But because cloud logging was automatically picking up all those error messages, I was able to capture it. And you can do cool things like reports and monitors on the logs themselves. So let's go back in and edit the source of our write BigQuery function and actually fix that error. Let me scroll down to the source. All right. And I will find write BigQuery, which is here, and I will fix this so that there's just one S in readings. Let's deploy that. All right. And again, going back to the sheet, you'll see that it's actually has been retrying this whole time. So we set up our Cloud Functions to retry on failure. So it'll do sort of this exponential back off, which if it fails, it'll immediately try again. But then if it fails a second time, it'll wait a little bit longer and then retry. And if that fails, it'll wait a little bit longer yet. So it's not just kind of hammering a service that's down. And so you'll see, actually, now that the new version has gone up, you'll start to see some of these trying failures retry and then ultimately end up successful. So we didn't actually lose any data. Our system recovered, and we didn't lose any of the sensor data that our IoT systems were submitting. So it should be all green and success. So hopefully this gives you a little bit of insight into how you can build a self-healing, resilient system using Cloud Functions and PubSub to build this decoupled, asynchronous distributed system.
Cool. Thank you, Brett. So which one of these products should you use for what type of application? Because you could build anything in App Engine or anything in Cloud Run, anything in Cloud Functions, but there are some types of applications where these three products are more or less suitable. So we put together this cheat sheet here, which I think is really handy. I go here whenever I build a new app to see which one of these three products should I use for computing. And we see here that a web app, for example, like we heard Dina was telling us before, a web app works great on App Engine. If you have more like HTTP services, microservices, Cloud Run is good for that. We saw web and mobile backends, could be either backend App Engine or Cloud Run. And we saw workflow and orchestration. That was what Brett was just showing in Cloud Functions. It can also be done in Cloud Run. So let's talk about some of these uh, in detail, what these architectures might look like, depending on what kind of apps we're building. Let's start with a web app. Very classical example. You want to serve up a web app to your users. What would you use?
App Engine. And this is the simplest architecture diagram ever. It is one box because App Engine comes with batteries included. You have everything you need already integrated into the service. So if you want a fully managed web app and you don't want to be like worrying about creating containers and choosing your runtimes and fixing in all of these special things, then App Engine is probably the right choice for you.
You could also build a web application with Cloud Run. Then you get a little more control, but now you have 3 boxes instead of 1. So a little more control, but a little more complexity. So you would build your container. You can build it, of course, using Docker on your local machine, but I prefer to build stuff in Google Cloud Build, up in the cloud. So you get consistent and fast builds. If you have a big team of developers, it's great to have them build consistently in the cloud. The result of each build becomes an entry into the container registry. Again, you can use your own container registry, or you can use the one that comes with Google Cloud Platform. You will have a list of all the versions of all your containers, and then you can deploy them and deploy them to Cloud Run. And so Cloud Run can run the one version you want to run, or 2 or 3 versions all at the same time in case you want traffic splitting. For example, if you're doing a canary deployment or a blue-green deployment and want to gradually ramp up traffic to your new version before you completely cut over.
And one thing I want to point out is that in products like Cloud Functions and App Engine, it's still essentially doing these same steps, but just sort of internally using, like sort of an internal version or the same version of Cloud Build or Container Registry. It's taking your source code, compiling it into a container, and then running it. But if you use Cloud Run, you actually get explicit access to use Cloud Build and Container Registry. So if you really want to customize your build or customize where your images are deployed, for example, Cloud Run lets you do that by actually exposing all 3 of these pieces for you to use explicitly and configure.
So that was web apps. Now, when we used to go to conferences and when we talked to developers, we used to run surveys. And I know, Brett, you ran a survey where you would always ask developers, what do you use serverless for? And this was one of the top use cases, right? The
Yeah,
APIs.
almost always the number 1 or number 2 most common response for what are you building with serverless was APIs. So we know it's a common thing that folks are asking for. So Martin, let's take a look at what's an architecture of what an API might look like on Google Cloud with serverless.
So if you're building a RESTful API, you can either use Cloud Run or App Engine. These are both really good solutions because they have all the HTTP endpoints. However, I would like to point out that these are both stateless products, and so they don't remember stuff in between invocations. And so you shouldn't try to store data inside these containers. So we keep the data in other products that are specifically built for data persistence, for instance, Cloud Firestore or Cloud SQL. So if you have a REST API, the user will ping the Cloud Run service, and then Cloud Run will get the data or manipulate data, post the data to one of these data persistence services.
And then as your organization grows and as your application grows and you have perhaps many different versions, many different kinds of mobile apps or web apps, you will eventually get to a point where you need more of these front-end services here and perhaps back-end services. And you might get to a system architecture that looks more like this. So if you imagine that the 2 Cloud Run symbols here on the left could be external services that your web or mobile apps are calling. They are exposed to the internet and visible from the internet. And they, in turn, can call internal APIs, internal services. Those are the two Cloud Run symbols in the middle of this graph. Those are not visible on the internet, and you must have special access to call them. And we can set that up with Cloud IAM. So external and internal services. Sometimes you hear people call them applications. Sometimes people call these cloud services. Sometimes if you have a lot of them and they all are responsible for small piece of functionality, sometimes people call them microservices. Some of these could then have privileged access to other cloud assets you might have, like compute engine or special databases, other things you have within a VPC security parameter, stuff that's not visible to the internet.
And not only can you secure these certain resources by putting them in your VPC, but you also can control access rights to your Cloud Run services. And you can do that in two ways. One, you can control what can your Cloud Run service do. And one of these ways is putting it in a secure VPC. Another one is by granting identities of these services and saying, these identities only have rights to these certain parts of Google Cloud. So for example, I want my Cloud Run service to be able to read from a cloud storage bucket, but not write to a cloud storage bucket. So you can control what these services do. And then you also can control who can invoke these services. So in this diagram, for example, you can say service A can invoke service B, but only service A can invoke service B. Some other service can't go ahead and call service B. So you can have Google Cloud IAM manage those permissions for you. What can your service do and who can call your service?
That was APIs. We see that another very common use case is data processing, or you might be familiar with this as ETL, extract, transform, load.
Yeah, I've spent most of my career building ETL pipelines, so this is near and dear to my heart. So let's talk a little bit about what ETL is, what data processing is. You have data coming in from another system, a sensor, whatever, and you want to transform it somehow. You might want to be, taking the median or converting it to another currency or combining it with more data from another system. For example, once a day, somebody uploads a file with 1 million records into cloud storage, and you want to push it into your analytics dashboard and pull the daily averages in. And so I love using Cloud Run for data processing because I get to choose my runtime and my libraries. I get to choose all the tools that I'm really comfortable with. And all the authorization, scaling, and event triggers are handled by PubSub and Cloud Run. And so I generally prefer to use Cloud Run over Cloud Functions because it offers concurrency and has longer timeout times. And if you're doing decent size bits of data, like we were talking about 1 million rows, then this is a good option to use.
And the last major use case we see for serverless is automation. This is the kind of glue that we heard Dina was talking about before. This is where we have events out there in the world. It could be IoT events, it could be webhooks, it could be changes in your Google Cloud project, it could be mobile clients, other services, changes in databases and files. And when those changes happen, you need some simple logic to write. And typically you want something else to happen. Like we saw in Brett's demo here, there was a cloud function there that triggered when a reading came in from the field. It sent something off with PubSub so that it was nice and robust and asynchronous, and then various other things in the cloud happened. For example, in Brett's demo, the data was saved to 2 different databases.
And not only can you do this for data as it flows around your system, but you also can do it for managing your actual infrastructure in the cloud. So I like to call this using serverless for your servers. And Martin alluded to it much earlier in the presentation, but a lot of times from the DevOps or sort of the sysadmin side, you've got things that you want to keep an eye on. And serverless can actually be a really nice way to automate some of those processes. So one of the things you can do is you can emit what are called audit logs, which are sort of infrastructure changes within your Google Cloud project. So a server is deleted or a new user is added to the project owner role or something like that. And maybe you want to have cloud functions that are watching these logs and they want to send some alert or take some action. So for example, if you see that the server that's running your database has been shut down, maybe you want to restart that, or maybe you want to email the DBA to go and take a look, or if a firewall rule changes, you want to have some alert go out so some human can manually detect it, or there's some scaling event that happens. You can have these cloud functions that are actually watching what is happening with your infrastructure in Google Cloud and then letting you know or taking some action to fix it. So using serverless to manage your servers. And we see a lot of customers using this approach.
So thank you for joining us when we talked about serverless technology. When we come back, we're going to be building a web application from scratch. We will be doing hands-on learning. And then after that, we'll be answering your questions. So anything you want to know about serverless, you come to the right place. Stick around for the Q&A and we'll be happy to help.